What if I told you that a single Louisiana mechanic discovered a fuel injection trick so devastating that it forced the NHRA to rewrite their rulebook? We're talking about a modification so subtle that tech inspectors couldn't even see it, yet so powerful it added 50 horsepower with nothing more than a different spray angle. This is the story of how Warren Johnson, a former Minnesota schoolteacher turned drag racing genius, outsmarted the entire pro stock establishment with a piece of engineering brilliance that was hiding in plain sight. Picture this. It's 1987, and the pro stock class is locked in the most intense technological arms race in drag racing history. Every team is fighting for single-digit horsepower gains, spending hundreds of thousands of dollars on exotic cylinder heads, custom camshafts, and precision-machined components. The difference between winning and losing is measured in thousandths of a second, and somewhere in a modest shop in Louisiana, Warren Johnson is about to turn the entire sport upside down with a discovery that cost him less than $50 to implement. This Louisiana mechanic outsmarted NHRA with a banned fuel injection trick that made 700 horsepower from naturally aspirated engines when everyone else was stuck at 6 soda. But here's the kicker. He did it with a modification so elegantly simple that when NHRA officials finally figured out what was happening, they couldn't believe they'd missed it. Johnson hadn't added any exotic parts. He hadn't increased displacement. He hadn't even changed the amount of fuel being injected. He'd simply changed the angle at which the fuel entered the engine, 15 degrees. That's all it took to revolutionize pro stock racing. To understand the genius of Johnson's discovery, we need to travel back to the mid-1980s when pro stock was undergoing a fundamental transformation. The class had just transitioned from carburetors to electronic fuel injection, and teams were scrambling to understand this new technology. The NHRA had mandated the switch to make pro stock more relevant to production cars. But the rules were strict. Teams had to use production-based blocks, limited displacement to 500 cubic inches, and most importantly, they had to use approved fuel injection systems with specific, unmodified components. The fuel injection rules were particularly detailed. Injectors had to be stock units from approved manufacturers. Flow rates were regulated. Fuel pressure was limited. The NHRA thought they'd covered every angle to keep the playing field level. They specified injector size, flow rate, fuel pressure, even the type of fuel rails teams could use. But they'd overlooked one critical detail, the spray pattern, and that oversight was about to make Warren Johnson the most dominant force in pro stock racing. The problem every pro stock team faced in 1987 was fundamental to internal combustion engines. How do you get fuel and air to mix perfectly in the fraction of a second available between injection and combustion? In a pro stock engine spinning at 9,000 RPM, each intake valve is only open for about 0.013 seconds. That's 13 thousandths of a second to inject fuel, mix it with air, and get it into the cylinder. The standard fuel injectors, everyone was using shot fuel straight down the intake port like a garden hose. It worked, but it wasn't optimal. The fuel would hit the back of the intake valve, splash around, and hopefully mix with the incoming air. Some of it would puddle on the port walls. Some would remain in large droplets that wouldn't burn completely. It was inefficient, and in a class where every horsepower counted, inefficiency was death. Warren Johnson approached this problem like the trained engineer he was. Before becoming a drag racer, Johnson had taught industrial arts and understood fluid dynamics, combustion theory, and most importantly, he understood that sometimes the biggest gains came from the smallest changes. While other teams were focused on making bigger ports, higher flowing heads, and more aggressive camshafts, Johnson was studying what happened to fuel after it left the injector. His breakthrough came during a particularly frustrating test session. Johnson's engines were making good power, around 675 horsepower, but they were prone to detonation when he tried to lean out the mixture for more power. detonation is the enemy of performance. It's when the fuel-air mixture explodes instead of burns, creating massive pressure spikes that can destroy pistons, bend rods, and crack blocks. Most teams dealt with detonation by adding more fuel, which cooled the combustion chamber but also reduced power. It was a compromise nobody wanted to make. Johnson realized the problem wasn't the amount of fuel, it was how that fuel was being delivered. The straight-down spray pattern was creating fuel-rich zones near the valve and fuel-lean zones in other parts of the combustion chamber. These inconsistent mixtures were causing hotspots that triggered detonation. If he could get the fuel to mix more evenly with the air, he could run leaner overall mixtures without detonation, and leaner mixtures meant more power. The solution came to him while watching a garden sprinkler. The sprinkler didn't shoot water straight up, it shot it at an angle to achieve better coverage. What if fuel injectors could work the same way? Instead of spraying straight down the port, what if they sprayed at an angle that promoted better mixing? Johnson took a set of standard fuel injectors back to his shop and started experimenting. The modification itself was almost laughably simple. Using a precision milling machine, Johnson carefully machined the injector nozzles to change the spray angle from 0 degrees to 15 degrees. The injectors still flowed the same amount of fuel, they still operated at the same pressure. To anyone looking at them, even closely, they appeared completely stock. But that 15-degree angle changed everything. When Johnson fired up his modified engine, the results were immediate and shocking. The engine sounded different, crisper, more responsive. On the dyno, the numbers were staggering. Where his previous best had been 675 horsepower, the engine was now making 725, 50 horsepower. From changing a spray angle, that's a 7.4% increase in power with no additional parts, no increased displacement, no exotic modifications, just a different spray pattern. But the real advantage wasn't just the peak power number. The angled spray pattern had fundamentally changed the combustion characteristics of the engine. Johnson could now run air-fuel ratios of 13.2.1 instead of the 12.8.1 he'd been limited to before. That might not sound like much, but in racing terms, it was revolutionary. Leaner mixtures burn faster and more completely, creating higher cylinder pressures and more power. The improved atomization from the angled spray meant smaller fuel droplets that mixed more thoroughly with air. The result was a more homogeneous mixture that burned more efficiently and was less prone to detonation. Let me put this in perspective. In 1987, a competitive pro-stock engine made about 1.35 horsepower per cubic inch. Johnson's modified engines were making 1.45 horsepower per cubic inch. That's the kind of specific output that wouldn't become common in pro-stock for another 5 years. He was literally half a decade ahead of the competition, and he'd done it with nothing more than a different spray angle. Johnson's on-track performance in 1987 was devastating. He qualified number 1 at race after race. His incremental times were consistently faster than the competition. In a class where races are won by thousandths of a second, Johnson was winning by hundredths. His Oldsmobile Cutlass was running elapsed times in the 740s when most of the field was stuck in the 750s. The competition knew something was different, but they couldn't figure out what. The beauty of Johnson's trick was its invisibility. Tech inspectors would check his engines after every race. They'd measure displacement, check valve sizes, verify camshaft specs, flow test the injectors. Everything checked out perfectly legal because, technically, it was. The NHRA rules specified injector flow rates but said nothing about spray patterns. They'd regulated quantity but not quality. Johnson had found the loophole of all loopholes. Other teams were going crazy trying to figure out Johnson's secret. They'd buy identical cylinder heads, copy his camshaft specs, even hire away his crew members. Nothing worked. Some teams suspected he was using illegal fuel additives. Others thought he had some kind of exotic ignition system. The truth was both simpler and more elegant than anyone imagined. While they were looking for big secrets, Johnson's advantage was hiding in a 15-degree angle that nobody thought to measure. The technical reason Johnson's modification worked so well comes down to fluid dynamics and combustion physics. In a standard fuel injection setup, fuel sprays straight down the intake port at about 60 feet per second. When this stream hits the back of the intake valve, it splatters in all directions. Some fuel droplets are large, up to 200 microns in diameter. These large droplets don't burn completely because the flame front can't penetrate to their center before the exhaust valve opens. It's wasted fuel that contributes nothing to power. Johnson's angled spray pattern changed this dynamic completely. Instead of hitting the valve straight on, the fuel stream hit at an angle that created a swirling motion in the intake port. This swirl broke up the fuel into much smaller droplets, most under 50 microns. Smaller droplets have more surface area relative to their volume, which means they evaporate faster and mix more thoroughly with air. The swirling motion also helped distribute the fuel more evenly throughout the combustion chamber, eliminating the rich and lean zones that caused detonation. The improved mixture preparation had cascading effects throughout the engine. Better combustion meant higher peak cylinder pressures, which translated directly to more torque. The more complete burn also meant less unburned fuel in the exhaust, which reduced exhaust gas temperatures and allowed Johnson to run more aggressive ignition timing. Every aspect of engine performance improved because of that simple spray angle change. By mid-1987, Johnson's dominance was becoming embarrassing for the NHRA. Here was one team destroying the competition week after week, and nobody could figure out how. The sanctioning body started investigating, sending their best tech inspectors to tear down Johnson's engines after races. They checked everything: bore, stroke, compression ratio, valve timing, fuel pressure, all legal. They even flow tested his fuel injectors, but the flow tests only measured volume, not spray pattern. The breakthrough for NHRA came almost by accident. During a particularly thorough inspection at the U.S. Nationals, an eagle-eyed tech inspector noticed something odd. When they removed Johnson's injectors for flow testing, tiny drops of fuel on the intake port walls showed an unusual pattern. Instead of being directly below the injector, the droplets were offset to one side. The inspector had the injectors tested on a spray pattern machine, a device normally used for testing agricultural nozzles, not racing injectors. That's when they discovered Johnson's secret. The injectors were spraying at a 15-degree angle instead of straight down. It was so simple, so elegant, and so completely unexpected that the tech inspectors initially didn't believe it could make any difference. They had to consult with engineers from the injector manufacturer to understand the implications. When those engineers explained how much difference spray angle could make to atomization and mixture preparation, the NHRA officials realized they'd been outsmarted. The ruling came down swift and harsh. Starting with the 1988 season, all fuel injectors in pro stock had to maintain factory spray patterns. Any modification to injector nozzles was explicitly prohibited. Teams would be required to submit sample injectors for spray pattern testing, and any deviation from stock would result in disqualification. The NHRA even mandated specific testing procedures to check spray angles during technical inspection. But here's where the story gets even more interesting. Johnson had anticipated this eventual rules change and had been developing other advantages in parallel. While his competitors spent the off-season trying to copy his now-banned injector modification, Johnson had moved on to optimizing intake port shapes to work with standard injectors. He'd learned so much about mixture preparation from his angled injector experiments that he could apply those lessons to port design, achieving similar results through different means. The 1988 season proved Johnson hadn't been a one-trick pony. Even with standard injectors, his engines were still making more power than the competition. He'd used the advantage from his injector modification to fund research into other areas: better ring seal, improved valve train dynamics, more efficient combustion chamber shapes. The injector trick had given him the budget and data to advance his entire program beyond what others could achieve. Johnson's innovation had profound effects on the sport beyond just his own success. Other teams started paying attention to mixture preparation in ways they never had before. The entire industry began developing better fuel injection systems with improved atomization. What started as one racer's clever modification led to genuine technological advancement that benefited all forms of motorsport. Today's direct injection systems, with their precisely controlled spray patterns, can trace their racing heritage back to Johnson's simple discovery. The angled injector saga also changed how the NHRA wrote technical regulations. They learned they couldn't just specify what parts teams could use, they had to specify how those parts functioned. The rulebook grew from a few dozen pages to hundreds, trying to close every possible loophole. But racers like Johnson had taught them an important lesson. Innovation will always find a way. What makes Johnson's story particularly impressive is the elegance of his solution. In an era where teams were spending millions on development, Johnson had found 50 horsepower with a modification that cost virtually nothing. He didn't need exotic materials or complex electronics. He didn't need a team of engineers or a massive R&D budget. He needed keen observation, understanding of fundamental principles, and the courage to try something different. The technical legacy of Johnson's angled injectors extends far beyond drag racing. The automotive industry took notice of how much performance could be gained through improved fuel atomization. Production car manufacturers began incorporating angled injection into their designs. Today's high-performance engines routinely use multi-angle injection strategies that can trace their roots back to Johnson's discovery. Modern direct injection systems, with their precisely shaped spray patterns delivering fuel at exact angles for optimal mixture preparation, are the evolutionary descendants of Johnson's modified injectors. Consider the numbers for a moment. Johnson's engines were making 700-plus horsepower from 500 cubic inches naturally aspirated on gasoline in 1987. That's 1.4 horsepower per cubic inch without forced induction, without exotic fuels, without variable valve timing, or any of the advanced technologies we take for granted today. For comparison, a modern NASCAR engine, with all its advanced technology and development, makes about 1.6 horsepower per cubic inch. Johnson was achieving 87.5% of modern NASCAR-specific output with 1987 technology and a spray angle modification. The financial impact of Johnson's advantage was staggering. Prize money, contingency payouts, and sponsorship bonuses meant that his injector modification was worth hundreds of thousands of dollars in direct earnings. But the indirect value was even greater. The dominance it provided attracted better sponsorship deals, allowed him to hire better crew members, and funded further development that kept him competitive for years after the modification was banned. Johnson's approach to racing was fundamentally different from his competitors. While they focused on making traditional improvements bigger and better, Johnson looked for inefficiencies in the system that everyone else ignored. The fuel injection spray pattern was just one example. He also pioneered techniques in ring seal, valve train dynamics, and combustion chamber design that were years ahead of their time. His background as an educator served him well. He understood that teaching himself the fundamental principles of engine operation would lead to insights that pure trial and error never could. The most remarkable aspect of Johnson's injector modification was how it highlighted the importance of mixture preparation in engine performance. For decades, racers had focused on airflow, bigger ports, bigger valves, better flowing heads. Johnson showed that how you introduced fuel to that airflow was equally important. You could have all the airflow in the world, but if the fuel didn't mix properly, you were leaving power on the table. This revelation changed the entire approach to engine development in pro stock. Teams began investing in sophisticated fuel injection modeling software. They started using high-speed cameras to study spray patterns. Injector manufacturers developed new nozzle designs specifically for racing applications. The entire industry elevated its understanding of mixture preparation because one racer had shown them what they'd been missing. The human element of this story is equally fascinating. Warren Johnson wasn't a wealthy team owner or a factory-backed operation. He was a self-funded racer who built his own engines, drove his own truck to the track, and often worked alone in his shop until the early morning hours. His victory wasn't just technical, it was a triumph of individual ingenuity over corporate resources. In an era when racing was becoming increasingly expensive and factory-dominated, Johnson proved that one smart person could still outthink entire engineering departments. The aftermath of the injector ban forced Johnson to innovate in other areas. He developed new techniques for reading spark plugs to determine optimal mixture distribution. He pioneered the use of individual cylinder fuel trim in pro stock, adjusting each injector's flow rate to compensate for minor variations in port flow. He even developed his own proprietary fuel injection management system that gave him advantages within the rules. The injector modification had been banned, but the knowledge gained from it continued to provide advantages for years. Other racers learned from Johnson's example. They started looking for their own loopholes, their own overlooked advantages. The sport became more technical, more sophisticated. Teams hired engineers specifically to read through the rulebook looking for opportunities. The cat-and-mouse game between innovators and rulemakers intensified, driving technological development at an unprecedented pace. The philosophical implications of Johnson's innovation are worth considering. Here was a modification that was completely legal when he developed it, provided a massive advantage, and was then banned specifically because it worked too. Well, it raises questions about the nature of competition and innovation in regulated sports. Should Johnson have voluntarily disclosed his advantage? Was the NHRA right to ban something that wasn't explicitly illegal when it was developed? These questions still spark debate in racing circles today. Johnson's angled injector trick also demonstrated the law of unintended consequences in technical regulations. The NHRA had mandated fuel injection to make pro stock more relevant to production cars. But by creating strict rules around that fuel injection, they'd actually encouraged racers to find creative interpretations that led to innovations far removed from anything on a production car. Johnson's modified injectors were technically fuel injection, but they were about as far from a production system as you could get, while still meeting the letter of the law. The story serves as a masterclass in problem solving. Johnson didn't try to overpower the detonation problem with exotic solutions. He stepped back, analyzed the fundamental cause, and addressed it with elegant simplicity. While others were treating symptoms, he was curing the disease. This approach, looking for root causes rather than applying band-aids, is what separated Johnson from his competitors. Looking at modern pro stock, you can still see the influence of Johnson's innovation. Today's engines make over 1 to 400 horsepower from the same 500 cubic inches, partly because the lessons learned from Johnson's experiments have been fully integrated into engine development. Modern fuel injection systems use precisely controlled multi-angle injection, sophisticated atomization strategies, and individual cylinder optimization, all concepts that can trace their heritage back to Johnson's simple discovery that spray angle mattered. The banned injector story has become legend in drag racing circles, told and retold with various embellishments over the years, but the core truth remains remarkable even without exaggeration. One man, working largely alone, discovered a simple modification that revolutionized an entire class of racing. He forced a major sanctioning body to rewrite its rules. He influenced fuel injection development across all forms of motorsport, and he did it all with a 15-degree angle that nobody else had thought to try. Warren Johnson's career continued successfully long after the injector ban. He won multiple championships, set numerous records, and became known as the Professor for his analytical approach to racing. But racers and engineers still consider the angled injector discovery his masterpiece, a perfect example of how deep understanding of fundamental principles combined with creative thinking can produce revolutionary advantages. The story also illustrates the crucial importance of looking where others aren't. While his competitors were focused on traditional performance modifications, Johnson was studying spray patterns. While they were adding complexity, he was finding elegance in simplicity. While they were spending fortunes on development, he was achieving better results with clever thinking. It's a reminder that in any competitive field, the biggest advantages often come from questioning assumptions that everyone else takes for granted. Today's racers still study Johnson's approach, not to copy his specific modifications, but to understand his methodology. How did he identify overlooked opportunities? How did he validate his theories? How did he implement changes without attracting attention? These lessons apply far beyond drag racing to any field where innovation and competition intersect. The technical specifications of Johnson's engines during the angled injector era remain impressive even by today's standards. His engines produced peak torque of 625 lb-ft at 7,200 rpm and held above 600 lb-ft from 6,500 to 8,000 rpm. That's a torque curve that modern naturally aspirated engines struggle to match. The specific fuel consumption was remarkably low for a racing engine, around 0.42 pounds per horsepower hour, indicating exceptional combustion efficiency. These numbers prove that Johnson's advantage wasn't just about peak power, it was about overall engine efficiency and performance across the entire operating range. The angled injector modification represents something profound in the history of motorsports, the moment when fuel injection truly came of age in drag racing. Before Johnson's discovery, teams were essentially using fuel injection as a glorified carburetor, focusing on fuel delivery quantity rather than quality. After Johnson showed what was possible with optimized spray patterns, the entire sport began to understand fuel injection as a precision mixture preparation tool. This shift in thinking accelerated the development of electronic engine management, individual cylinder tuning, and the sophisticated fuel injection strategies we see today. Warren Johnson's angled injector trick wasn't just about making more horsepower. It was about seeing what others missed, questioning what others accepted, and having the courage to try something different. In a sport obsessed with going fast in a straight line, Johnson found his advantage by thinking at an angle, 15 degrees to be exact, and those 15 degrees changed drag racing forever. What's your take on Johnson's innovation? Was it clever engineering or bending the rules too far? Drop your thoughts in the comments below, and don't forget to subscribe for more stories of motorsport innovation that changed the game. Because if there's one thing Johnson taught us, it's that the next revolutionary advantage might be hiding in plain sight, waiting for someone smart enough to see it.